welcome to this new tutorial. Here we have the file. You can find the link in the description. It comes with the bricks and the flowers. First, we are going to create the land. We are going to use a new node called duplicate elements. So you plug something, you select element is going to be duplicated. You select the amount. The amount can be a field. You can use a noise, index, or whatever to create duplicates. This number, it won't copy, it's just the number you already have. It needs to be integers, so 1.5 will still be 1, but if you have a value of 2 points, in this case, you will have 2 points at the same place. They are copied in the same exact spot. The duplicate index will give you the number of copy. The original elements have a number of 0 here, and the first copy has a number of 1, and so on. So you can then use it to target or select the copy, the second copy, third copy, and so on. We are going to base everything on this node. We are going to use a grid as a base of our terrain. We need to define the size and the amount of vertices here. So I'm using an integer here. Let's say for now 3 by 3. And to calculate the amount of bricks I need, I will take the same number, vector math. I will divide this number by 0.2. That's the size of the bricks. So this will give me how many bricks fit on the size of this. But since the bricks are instanced on the point, you have half a brick that will go to this side and half a brick that will go to this side. So we need one more to fully complete the grid. Let's create an instance on points. We'll leave this here for now. And we are going to use a collection info. Tierra means terrain, or you use that. We connect here. We separate the children's, and we have this. You see the separation is, if you take all the separations, you will have one more brick. So you just add one, and there we have. We will expose this size, a minimum of 1 maybe, 3, maybe 1, and 10. So now we have this. Okay, now we will use this to create the height of the terrain. We'll plug this here. Now it's 1 copy, so everything is the same. And I will use noise to assign value to the different vertices there. I will use 4D to have a seed here. I will change the scale to around 0.3. We need also to multiply this value, because as you remember, this will be the number of copies, and this has an output of that goes from 0.25 to 0.75. If you play it directly, you won't have any copies because it's not even 1. So we need a multiply. We plug this here and we multiply it, for example, by 5. The copies are there, but they are on the same spot, so we cannot see it. Now we have to take care of that. I will use a set position, and I will use my duplicate index to move them on the z-axis. Since my bricks are 0.1 in height, I will multiply it by that number, and then we need combine on the z-axis, and we plug this on the offsets. Now this is working on some spots. Since this was 0.75, the maximum, even if it is by 5, you get 3 copies on the maximum size here, and then we can just increase this value. But since the minimum number is not 0, we are getting a value on the lowest part too. So now I need to change the range of this to make this reach the 0 too. I will use a map range, and I will set this to around 0.42. And the last thing I want to do, you can keep it like this if you want. Maybe you want to have terrain and parts without, but I'm using water as the lowest level. So I'm going to use multiply add and add 1. So I'm always having at least a value of 1. And this will be my control in height. I will expose this value too. I will copy here like this here. This is my height. If this number looks too high, you can just multiply this by 10 maybe. I will decrease it first, multiply by 10. To create the scrolling effect, I will use a position, a vector math, and I will add value to this position. I plug it here. This is exactly the same. And now if we move, for example, next, we have this. In my case, I'm only using scroll on one axis, so I will expose this. It's important to note this is the positive side of X. When I increase the value, the terrain moves, the other side moves left. This is because the noise is based on the position. I'm increasing value on X. The 0 is here, but if I add 1, for example, that 0 now becomes 1. The original 0 is here now, so it moves left. This is important because when we create the flowers, we are going to, instead of adding, we are going to subtract, because we are going to subtract a position from the flower to make it go left also. So this will be add, and the other one will be subtract, and it can be confusing, but that's the reason. Combine XYZ. To make this work with the flowers too, I have to make movements of one brick at a time. I cannot have a brick move like half a brick or less than the size of the brick. So we are using a math node and a snap with the size of the brick, 0.2. This will be on X, and this will be my scroll. I won't limit this. I will just put the default to 0. To take care of the color, I will use the pick instance that lets me choose which instances get instanced on the different points. And I will use the index to alter my index here. I will explain. If I activate this, we will get a repetition of the 5 different bricks that we have. When they reach 5, it goes back to the first one and so on, using the index that they have at this point. So what we are going to do is to alter this index. I'm going to use this one instead. If you plug it directly, you will see that we start to have something. This one is the first one, and when it reaches the last one, it goes back to the first one again. If I want this repetition not to occur, I have to limit the value that they can have to my maximum amount of copies. I have 0, 1, 2, 3, 4. So I will use a clamp and limit this from 0 to 4. And the other thing, you can leave it like this if you want. I want more than one color here for the sun, for example. So I can use multiply add. I will multiply this by a number lower than 1, 0.25. But I will add to complete 1 with this one, 0.75. Now, the water only takes one place, and this number will determine how many of the bricks I use with each of the other bricks. But we always have to compensate here. So this will be 0.92 in this case. That's up to you how many of the bricks you want. In my case, I use this. Okay, for now, this is our terrain. I will select everything, Control J, rename terrain. We can control the size, the height, the scroll, and I will add the seed. Now with the seed, you have different terrains. Okay, we are going to use the same base grid we used here. So I'm going to take this out and I will use it on a set position. I have to calculate the height for the flowers. They have to be on the last brick of each place on the grid. And that information comes from this value here. Okay, so we take this number, we use a math node, we will use floor. This will do exactly what we want, get rid of the fractions, and we'll get rounded down. This is giving me the amount of bricks. It's still not the height. And then we will multiply it by the size of our bricks, 0.1. We plug this to a combine, and we plug this to the offset here. Let's plug it just to see how it looks. Change geometry, and we plug this. So you can see it's a plane, but every point it's at the maximum height possible. Okay. Now we will use a capture attribute to capture the index of these points before we make changes to them, and then the amount will change. So I want the index to be fixed. I will use a index here. I'm capturing an integer for the points. I will then instance on those points. I will use a collection info because we could have more than one kind of flower, or maybe other things like trees or rocks or whatever. So I'm going to use this. We use flowers, separate children, and we connect here. Okay, to start, first remove the ones from the water. So to do this, we will use a position. We will separate this, and we will use our set, that's the height, on a greater than operation. This is the math node, and I will add the height of one brick and a bit more, 0.12, for example. What I'm saying is that only use the ones that are greater than this position, because that will leave the first brick outside of this condition. If I plug this in my selection, the ones that are underwater are gone. And I need another condition to remove some of the flowers. I will use my index on a white noise. This will change the values of my index to a range of 0 to 1. And this will be 4D. So we have a seed here also. We will then plug this to a less than operation of the math node. That means that only the ones that are less than the number I'm setting here will be used. So if I set this to 0.1, for example, that will be the 10%, because this is now a factor from 0 to 1. 1 will be all of them, and 0.1 is just 10%. If I plug this directly, of course, we have some 10%, but we have them on the water. So we need to add the two conditions together. To do that, we use Boolean math, and we say we need this condition and this condition to be true. So and we plug this here. And now it's working. I will expose some values, so I will duplicate this. This is my amount of flowers and my flower seed, 0 to 1, and flower seed. We can make some space. Every flower is facing the same exact angle. They are on the exact same spot on the brick. So I did this with a origin point here. So I will make them rotate a quarter of a rotation randomly. To make this, we will use a random value, minus pi. I will use my index on the ID to keep them with the same value, because when some flowers will disappear on the water, for example, the index number of others will change. But since we capture this, those numbers won't change, and we use that to keep this value fixed. We only want quarters of a rotation, so we will snap this. Pi divided by 2, that's a quarter rotation. We use this on a combine on the z-axis, and plug this on the rotation. And now we have random rotation and placement. We select everything, Ctrl-J, flowers. Now we have to take care of the scrolling, because if we move this, the flowers stay in place. That looks funny, but it's not what we want. And they just adapt to the height because of this. So we are going to use our scrolling that we have here. And as I explained you earlier, we're going to use vector math. And in this case, like this, is a position. And we are going to subtract from that position. We need another set position, and this has to happen before we set the position of the height. So we plug it here. If we plug this directly, let's set the scrolling to 0, plug this on the position. Everything looks fine, but as I scroll, it will work because they stay in place, but the plane goes away and it keeps going. The noise has this shape there, but we need the flowers to stay on the visible part of the noise that we are using here. What we need to do is to make them, as they reach this border, they go back to the beginning here. So to create that, we are going to use an operation called wrap. Duplicate this, we change this to wrap, and this behaves more or less like modulo, that you set a number and goes back to 0 every time it reaches that number. But in this case, we can pick the maximum and minimum. So we can say you have to stay between this number and this number. Now to define those limits, we plug this here. The limits will be based on the size of our grid. So we're going to use exactly that. We have it here. we will multiply that by 0.5. That's half of our terrain. Now I'll use this on a combine XYZ, and this is the value for my X. We are scoring on X, so we plug this on our maximum. Now they can move until they reach this, and they go back to 0, because this is 0 now. And now we have to set the minimum limit to negative, so multiply by -1. This is now this point on X, and we combine and plug this in the minimum. That's great, but since we are limiting Y to 0, they are on in the middle. For Y, we will just not limit it. We could use a high number here, like 200, -200. And now, if we move this, we have this working, because when the flowers reach the border, they spawn again on the other border. The last thing is an optional thing. If you want to make this hollow to save some processing time, you can use the position, separate, we'll use a less than. This is the height here, and then we will use another math node to add value. We use our set position here. Here, the geometry, we plug this here. As you can see, this is hollow here. This means that it's taking the height and leaving only this buffer or this offset of bricks down. If we decrease this, it's like thinner. Of course, if you have a difference of more than 1 brick in some places, you will start to have holes, so you have to be careful. And also, if the terrain is like more pronounced, you will also have holes, so you have to compensate a bit. But this is, of course, way less bricks than if we don't use this. So it's up to you. I can use mute here. We have 17,000 instances, and with this, we have 13,000. So it's quite a difference. If you like this content, you can support me on Patreon, so I can make more tutorials in English too. Thanks for watching, and see you on the next video.